Day 8, we're going to take a look at something called explicit form. For the warm-up, which one doesn't belong and why? So in class, we'll take a look at it, and students will choose which one they think doesn't belong, explain why, and we'll talk about like multiple perspectives on this problem. Then the lesson, we're going to take a look at first a review of the recursive formula. A recursive formula requires that you know the previous term in order to find the next term. So here's an example. This is saying the first term is 54. To find the next term, you subtract 2 from the previous term. So for the first problem, find a sub 4, it means find the fourth term, the fourth number in the list. So if the first term is 54, then we would subtract 2 and get 52. That would be the second term. The third term would be 50. Whoopsies. And the fourth term would be 48. Using the same sequence to find the 14th term, well, we could keep subtracting 14. We talked about how to program this in our calculator. So what we can do is we can program in our first term, 54, and hit enter. And then if we want to tell our calculator to subtract 2 from the previous answer, we'll just hit -2. So now every time I hit enter, we'll take the previous answer, ANS, previous answer, a sub n minus 1, and subtract 2. So here's the second term, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, and 13th, and 14th. So the 14th term here would be 28. So we can use a calculator, even Google Sheets, to program these sequences to find certain terms. It says this might not take too long to do, but is there a faster way where we can just plug in the 14, the term number, to get the answer? And there is. So we're going to take a look at that today. How can we write this thing called the explicit form, which is an equation that allows you just to plug in the term number that you want to find the answer versus hitting enter like 14 times. So to start, is this sequence linear, exponential, or one of the other functions we've looked at? And if we're just subtracting 2 every time, if we were to graph that, it would make a line. So this is linear. Use this to write an explicit formula and solve. All right, so if it's linear, we know we've used this form, slope-intercept form, y equals mx plus b. So we're going to do the same thing here. Well, first let's define what everything is. Here, m, this is your slope, and slope is the same thing as your common difference. And then b is your y-intercept. That would be the same thing as a sub 0. So if we rewrite this in terms of like n, the term number, to find any term, you take your common difference and you're going to multiply it by n, the term number, which is like x, and the y equals mx plus b, plus the 0 term, or the y-intercept. So let's do that for this sequence right here. Again, here are our numbers, and we can see the slope is -2. We're subtracting 2 every time. But notice we have the first term, but we want the 0 term, so we do have to go backwards to find the starting value, the y-intercept. So instead of subtracting 2 every time, if we go backwards, we'll add 2. And so that would mean that our y-intercept, our starting value, would be a sub 0. So if we're writing this function, we'd say, all right, to find any term, it's y equals mx plus b, and here our slope, we're subtracting 2 every time, so -2 times n, and the starting value was this a sub 0, or 56. So here's the explicit form, which means now if I want the 14th term, I could just plug in -2 times 14 plus 56. We already know the answer is 28, but let's check it. So -2 times 14, the term number, plus the y-intercept, which was 56. And we can see we get the 28 that way instead of hitting enter 13 times. So let's write that out. Another way to write this, you can switch the order of these two. So you could also write the explicit form as 56, where we start with, and subtract 2 every time. I tend to like writing it this way because we start at 56 and we're subtracting 2 every time, but they mean the same thing. So that's an explicit formula, which is a formula you can directly plug into, so you don't have to hit enter to find how many, like the answer after so many terms. So let's take a look at just some examples here. So here's the first example. A stadium with 75 rows has 10 seats in the first row, 15 in the second, and I have to define one more. So let's say there's 20 in row 3 and so on. So if I define that the third row has 20 seats, is this arithmetic or geometric? So we have 10, 15, 20 in the first row, second row, third row, and we can see it's arithmetic because there's a common difference of 5. Let's write the recursive formula. So in the first row, there's 10 seats. For any row, you take the row before it and you add 5 to that row. So now to write the explicit formula, I always like to start with the y-intercept. So again, we would need to go backwards. So here, instead of adding 5, we would subtract 5. So if there was a row 0, how many seats would be in there? And we would subtract 5. There would be 5 seats in the 0 row. So 5 seats to start out with. And then we're adding 5 every time. That's our common difference. So plus 5 for every row that we go up. So here's an explicit formula. Again, here's the starting value, a sub 0, and this is your common difference. We add 5 every time. Find a sub 6 and explain what it means in terms of the stadium. Well, now instead of hitting enter, like programming enter calculator, hitting enter 5 times, to find the 6th row, which is what this means, we can plug in. So a sub 6 equals 5 plus 5, and now instead of n, we can type in a 6 because we're trying to find the 6th row here, and then solve. So 5 times 6 is 30, 30 plus 5 is 35. So a few ways to get the answer. You can use the explicit form, you could program into your calculator, or you could just add 5 and keep getting the terms of your sequence. So what this means is there's 35 seats in the 6th row. Okay, which row has 50 seats? Okay, so now here you can again keep hitting enter and count like how many rows until you get to 50 seats, or now we have the explicit formula, so we can do 50 equals 5 plus 5n, n is the row number, and we can solve that algebraically. So again, multiple ways to solve problems in math, including with sequences. So we get, it looks like the 9th row. Okay, example 2. Is this arithmetic, geometric, or neither? Okay, so the first one we add 4, and then we're adding 4 again. Okay, it looks like we're adding 4 every time, so this is arithmetic. Write the recursive formula. So in the first term, we get 5. To find any number, we take the number before it, and we add 4. Write the explicit formula. Okay, so for any row, we start at 5, but actually we need the y-intercept, so we have to go backwards. So instead of adding 4, let's subtract 4. So a sub 0 will be 1. So here we start with the number 1, the y-intercept, and we're adding 4 every time, so plus 4n. Okay, so now find a sub 14. So again, you can just type in your calculator, hit enter 13 times. But for a sub 14, we can do 1 plus 4 times 14. And then get our answer. So that would be 57 for a sub 14. So the 14th number is 57. Which term number is the answer 101? So now we're looking at, all right, what term? So n we're solving for. We can subtract 1 from each side. We get 100 equals 4n. Divide by 4. So n equals 20. So the 20th number is 100. The 14th number is 57. Okay, let's look at the next example. Is this arithmetic, geometric, or neither? This is definitely geometric, right? We're multiplying by 3 every time. Whoopsies. Write the recursive formula. All right, so there's 2 ways to write this recursive formula. So I'll write up both. Actually, no, sorry, there's 1 way to write the recursive formula, 2 ways to write the explicit formula. The recursive formula, we can say the starting value is 1. To find any number, you take the term before it and you multiply by 3. So there's the recursion. To write the explicit formula, 1 way is to start at the first term, and the first term is 1. So we can say to find any number, we take 1 and we triple it every time, but we have to shift it 1 to the left because we're starting at the first term, not the 0 term. You need this n minus 1 to shift it back 1. Or, and this is the way that I prefer, if we have the 0 term. So the 0 term would be going backwards. So if the first term is 1, the 0 term, instead of multiplying by 3, would divide by 3. So here the 0 term is 1/3. So right here, we start with our 0 term, we're tripling it every time, and then you don't have to shift it because you already did with that 0 term. So there's 2 ways to write this. To find the 8th term, again, you can use either equation. So to find the 8th term, I'll show you both ways. Oopsies. It is 1 times 3 to the 8 minus 1 or 7th power. Or to find the 8th term, it's 1/3 times 3 to the 8th power. Either way, when you type that in your calculator, you should get the same answer. And so let's type that in. Okay, so I'll just do the 1/3. 1/3. Ooh. 1/3. Okay, so times 3 to the 8th power, and there's our 8th term equals 2,187. Okay, let's pop that down. Okay, so there it is. You just plug in for n, and you get that answer. Either way, you should get that. Which term has this answer? Okay, so again, you can just program in your calculator and count until you hit this number. How many times do you hit enter? Or we can use a log to solve. And I'm just going to use, I'll just use this equation right here. Okay, so here we go. Change colors. 177,147 equals 1/3 times 3 to the n. All right, first step, we can get rid of this 1/3, either dividing each side by 1/3, or that's the same as multiplying by 3. So we multiply each side by 3, that cancels. So we get this big number, 531,441 equals 3 to the n. You can use guess and check to solve from here. 3 to what power equals that? But I would probably want to use a log. So it's log base 3 of 531,441, and that will give us our term number. If you type that in, you get the 12th number in the list. So several ways to solve this. I prefer a log, but you can program in your calculator and count. You can use guess and check. Several ways to solve. All right, example 4. Suppose you drop a tennis ball from the height of 15 feet. All right, this is the initial height. So in this case, this is actually a sub 0, the starting height. After the ball hits the floor, it rebounds to 85% of its previous height. So this is decay. How high will the ball rebound after its third bounce? Round to the nearest tenth. This is definitely geometric because we're multiplying by 0.85 every time. So here, we can say that the 0 term is 15. To find any term, we take the term before it and multiply by 0.85. So that's one way to write this. Find a sub 3 is what it wanted. So, okay, let's write the explicit formula first, is what I would do. Or we can program it into our calculator. All right, so the explicit formula, to find any number, you take the 0 term to the n power. Since we're starting at the 0, we go to the n power. So this says find the 4th term. Okay, so fine. 4th term equals 15 times 0.85 to the 4th power. If you wanted the third term, you'd plug in a 3 there for the exponent. So this is about 7.83 feet that it would rebound to. Which term is 12? So when does it hit 12 feet is what it's asking. So 12 equals 15 times 0.85 to the n. Here you can use guess and check to solve. I'll use a log, so divide by 15. We get 0.8 equals 0.85 to the n power. You would log this, the base is 0.85. So log 0.85, and then you loop it around. 0.8 equals n. So n is about 1.373. So a little bit after the first bounce, it would hit 12 feet again. So to review, if it's arithmetic, it's also linear. You want y equals mx plus b. You need the common difference and the y-intercept, so you can plug that in. If you take a look, here's an example. 5, 7, 9, the starting value is 5, the common difference is 2. If you want the 0 term, we would do 5 minus 2, go backwards, and then the explicit form, a sub n equals 2, the slope, times the term number, plus the starting value of 3. If it's exponential, we're looking at, if it's geometric, it's exponential, so a times b to the x. So 2 ways to write it, either with the 0 term times the ratio to the n power, or the first term times the ratio to the n minus 1 power. So here's an example you can take a look at. We're starting at 4. It's being multiplied by 2 every time. So either you can go backwards and start at the 0 term, which is 2, and write this Oh, this first equation right here, this should be, see if I can erase it without erasing everything. Okay, so if you start at the 0 term, this should be to the n power. Or if you start at 4, which is the first term, it'd be the n minus 1. So your assignment is to practice day 8. I'll post this answer key online so you can check your answer.